Differences between has said, linked has said, and tree said. Three you studied, no? How many differences I give? 6. Seventh one also write it. Seventh one, it supports both homogeneous and heterogeneous elements. It supports both homogeneous and heterogeneous elements. It supports both homogeneous and heterogeneous elements. It supports homogeneous elements only. It supports both homogeneous and heterogeneous elements. It supports both homogeneous and heterogeneous elements. It supports homogeneous elements only. Is it over? It supports both homogeneous and heterogeneous elements. It supports both homogeneous and heterogeneous elements. It supports homogeneous elements only. Okay. It is left side. What is first one? Has said. Second one. Third one. Tree said. Tree said supports homogeneous only. Okay. Now. Homogeneous, heterogeneous, both, and one is last one only homogeneous. Next. Differences between hash map, linked hash map, and tree map. Differences between hash map, linked hash map, and tree map. Differences between hash map, linked hash map, and tree map. You've seen hash set, linked hash set, tree set. Now hash map, linked hash map, tree map. Is it over? See. Hash map, linked hash map, tree map. hash map. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of red black tree or binary search tree technique with linked representation. It is an implementation of hashing technique with array representation. It is an implementation of hashing with linked representation. It is a technique with linked representation. See, hash set, linked hash set, tree set. 7 differences you have seen. Okay. There. Second difference, what is there? What I given? What I given? It occupies less memory. Now, here also same concept. It occupies less memory. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. It occupies less memory. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. Tree map is linked representation or array representation? Linked. That's what it will occupy more memory. Is it over? First one, hashing technique with array representation. Here hashing technique with linked representation. Here red black tree technique with linked representation. Here less memory. More memory because data stored in nodes. Here more memory because data stored in nodes. Okay. Same differences between hash set, linked hash set, tree set is same differences comes. What is third difference I given yesterday? What is that? Unordered concept. Now, third one, it is an unordered map. It is an ordered map. It is sorted map. It is an unordered map. It is an ordered map. It is a sorted map. Fourth difference what I given? Here insertion order is not preserved. Here insertion order is preserved. Here insertion order is not preserved. Is it over? It is an unordered map. It is an ordered map. It is sorted map. Here, what will happen? You cannot predict the output based on hashing algorithm output. Here, whatever our order, here ascending order, descending, ascending order, alphabetical order comes. Here, not preserved because you are not predicting output. Here, you can predict the output. Here, sorted. That's what not preserved. What I given fifth? It allows one null key and allows and one null key and many null values. It allows one null key and many null values. It allows one null key and many null values. It does not allow null key and allows null values. It does not allow null key and allows null values. Sixth one, initial capacity. Say hash set, linked hash set, tree set. Like that only hash map, linked hash map, tree map. Okay. Is it over? Sixth one. Here default initial capacity is 16. Here, default initial capacity is 16. Here, default initial capacity is 0. Here, default initial capacity is 16. Here, default initial capacity is 16. Here, default initial capacity is 0. It supports both homogeneous and heterogeneous key value pairs. It supports both homogeneous and heterogeneous key value pairs. It supports homogeneous key value pairs only. See, it supports both homogeneous and heterogeneous key value pairs. It supports both homogeneous and heterogeneous key value pairs. It supports homogeneous key value pairs only. Is it over? Say, has set, linked as set, tree set. Like that only, but only difference one-dimensional collection, it is two-dimensional collection. That is only difference. Remaining concept same, no? Is it completed? Now, one more also write it. Difference is over. One more concept. One side sets, one side maps. As set, linked as set, tree set. Hash map, linked hash map, tree map. These are one-dimensional collection classes. These are two-dimensional collection classes. These are one-dimensional collection classes. These are two-dimensional collection classes. These are one-dimensional collection classes. These are two-dimensional collection classes. These collections contain elements. These collections contain key value pairs. These collections contain elements. These collections contain key value pairs. Will it allow duplicates? No. Will it allow? No. These collections do not allow duplicate elements. These collections does not allow. These collections do not allow duplicate keys. Values may be duplicated. These collections do not allow duplicate elements. These collections do not allow duplicate keys. Values may be duplicated. Is it over? Fourth difference. These are index-based collections. These are key-based collections. These are index-based collections. These are key-based collections. These are index-based collections. These are you studied starting set map differences, no? Same. Set is one-dimensional. Map is two-dimensional. Set contains elements. Map contains key value pairs. Set does not allow duplicate element. May be duplicated. Set is index-based. Map is key-based. Okay. These are sets, maps, differences. Up to here, total 8 collections completed. See, first one, what is the first one? Array list. Second one, linked list. Third one, hash set. Fourth one, linked hash set. Fifth one, tree set. Sixth one, hash map. Seventh one, linked hash map. Eighth one, tree map. Ninth one, priority queue. 10th one, array deck. Okay. Out of 10, 8 completed. Now I'll ask some questions. Give me answer up to 8. In these 8 collections, how many collections do not allow null? How many? 2. What are those? Tree set, tree map. Okay. Out of 8, how many do not support heterogeneous? Same. 2. Tree set, tree map. These two not supported heterogeneous. Okay. How many allows duplicates? Allows duplicates. Allows duplicates out of 8. In a maps, keys only consider. How many? 2. What are those? RL is linked list. Okay. Sets, no duplicate. Maps, no duplicate keys. Values allowed. Okay. In this 8, how many one-dimensional? How many? 5. Up to tree set. Remaining maps are 2-dimensional. In this 8, how many linked representation? How many linked representation? 5. This is linked. This is linked. This is also linked. It is linked. It is linked. What is the initial capacity of array list? Here, 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 here. Load factor. No load factor. Here, here, here. No load factor. Here, here, here. Load factor. Okay. These only interview questions. Okay. Remember these all. Next, priority queue. Next one, priority queue. Nodan, a priority queue is a queue in which elements are inserted and deleted based on priorities. A priority queue is a queue in which elements are inserted and deleted based on priorities. Here priorities are compared comparator interface. Here priorities are compared by using java.util.comparator interface. Here priorities are compared by using java.util.comparator interface. Here priorities are compared by using comparator interface. So elements are inserted, deleted based on priorities, but priorities are compared with this interface. This interface comes under next category. Okay. Now it is an implementation of heap tree data structure. With linked representation. It is an implementation of heap tree data structure with linked representation. There are two types of heap trees. Minimum heap tree, maximum heap tree. There are two types of heap trees. Heap tree. There are two types of heap trees. First one, minimum heap tree. Second one, maximum heap tree. Minimum heap tree, maximum heap tree. I'll explain. Just note down minimum heap tree. Minimum heap minimum heap tree is a complete binary tree
Recording in progress.
First, what is complete binary tree also required? Next, complete binary tree. A binary tree is said to be complete binary tree otherwise, okay, a binary tree is said to be complete binary tree if the tree without missing node number. A binary tree is said to be complete binary tree if the tree without missing node number. Node? I'll explain. First, what is binary tree? Maximum 2 child nodes. Okay, maximum 2 child nodes. Maybe 0 or 1 or 2. 3 is there, it is not binary tree. Complete binary tree means if the tree without missing node number. So actually, this is one node first. This node number 0. This node number 0. Next child node, left child node. Next right child node. It is 1. It is 2. 3. It is 4. It is 5. It is 6. Okay. Now 0 to 6 node is not missed. It is complete binary tree. Now also not missed. 0 to 7. It is complete binary tree. Suppose without right side, if node is here, this node number 9. One node is missed. No? Here one node is missed. It is not called complete binary tree. If this is not there, 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 complete binary tree. Suppose without this is there. Is it complete binary tree? No. Missed. Missed means not complete. But suppose if it is like this. Now, is it? Yes. Is it complete binary tree? Yes. But it is called full tree also. Full tree. All levels are full. That is full tree. Complete binary tree different, full tree different. Full tree means it is full tree. It is complete binary tree also. But it is complete binary tree, but not full tree. Okay. So a binary tree is a tree in which each node has maximum 2 child nodes. So more than 2 child nodes is there, it is not binary tree. Without missing nodes, if it is there, it is complete binary tree. If all levels are full, that is full tree. And less than left side, greater than right side is there, binary search tree. And each node greater than its child nodes is there, maximum heap tree. Each node less than its child nodes is there, minimum heap tree. So many concepts are there. Only trees, only many concepts are there. B trees, B plus trees, AVL trees, so many are there. Okay. Here, complete binary tree without missing node number. That is complete binary tree. Heap trees are complete binary trees. Every heap tree is a complete binary tree. But here, trees are adjusted. Just you see, trees are adjusted. How adjusted? You observe. See, priority queue don't write priority queue PQ equal to new priority queue. Is it homogeneous or heterogeneous? Is it type safe or unsafe? Type safe. PQ dot add. Add is there. One more offer method also is there. PQ dot add. PQ dot add. If I write like this, 3 are written, you observe. PQ. You observe here what will be happen actually. First 56 stored here. Next, without missing node number. So left side. Left side. Here, what is stored? 83. Next, 45. Where it is stored? Right side. Now, is it binary tree? Is it binary tree? Yes. Binary tree means each node has maximum 2 child nodes. For this, how many child nodes? For this one, 0. For this one, it is okay. 0 also okay, 1 also okay, 2 also okay. Can I call binary tree? Yes. Is it complete binary tree? Yes. 0, 1, 2. It is complete binary tree. Okay. Is it binary search tree? No. Binary search tree means less than left side, greater than right side. It is not binary search tree. Now, is it minimum heap tree? No. It should be less than 2 child nodes. Is it maximum heap tree? No. It should be greater than its child nodes. What do you mean? Then what will be happen is here, this 45 comes here. 56 comes here. Now, is it minimum heap tree? Yes. These two less than. Now, 45, 83, 56. File, save. Java C demo.java. Java demo. See, 45, 83, 56. But what I given? 56. 8345 with heap tree algorithm tree adjusted. That's what 45, 83, 56. Suppose 23, 66, 85. Now what is output comes? 23, 86, 85. As it is comes. As it is comes. See. Okay. Now 93, 66, 85. What is output comes? 66, 93, 85. Tree adjusted. (66, 93, 85). Only 3 elements I given, very easy. If 20 elements are there. Last child node onwards, every node it has to check. Tree is going to be adjusted. That adjustment algorithms only, writing program only, almost 500-600 lines required for this. Now only 3 are given. That's what you can predict output. You can give answer. 25 give. From child node onwards, 2 child nodes, again root node, comparing. Like that, child is adjusted. Last least element comes out first. This program, you can predict only, suppose 20, 30 numbers if I give, you can predict only first element, whichever is least. That is at the top, because it maintains minimum heap tree. Okay. But these all not required in Java because you are not implementing. But understanding purpose I explained. Just note down. In a priority queue, minimum heap tree data structure implemented. Here always least element comes out first. 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 See, complete binary tree. It is based on, again, queue concept also is there. First in, first out basis concept. In the priority queue concept also implemented. Now, next write it. It supports, it allows duplicate elements. It does not allow null value. Here, default initial capacity is 11. Here, default load factor is 100%. It allows duplicate elements. It does not allow null value. Your default initial capacity is 11. Your default load factor is 100%. It supports homogeneous elements only. It supports homogeneous elements only. It allows insertion at rear end and deletion at front end. It allows insertion at rear end and deletion at front end because it implements queue interface. It allows insertion at rear end and deletion at front end because it implements queue interface. So you already studied about queue, first in, first out list, that type. But priorities will be compared. That is the reason priority queue. These all points, remember, don't forget. Here initial default capacity you observe 11. It is 100%. Okay. Hash map, linked hash map, hash table, set linked hash set 16. Tree set tree map 0. Linked list 0. And RLS is 10. Okay. Now it supports homogeneous only. Now you observe like this. Suppose you observe, I'll write some numbers randomly. I'll write numbers randomly. I'll write 5, 6 numbers. You observe 56, 23, 89, 66, 54. If I write, what will be happen? See, first what it comes 56. First as it is 56 without missing node number. Then next 23. Next 89. Next 66. Next 54. Now heap tree concept checked. Okay. first 56 here added, next 23, next 89, next 66, next 54. Now each node should be less than its child nodes. First year checked 66, 54, 23. Is it least? No. It is okay. Next year checked. Year not their child nodes. Now year checked 23, 56, 89. What will happen? 23 comes here, 56 comes here. Now again here checked. Okay. 54 comes here. 54 comes here. 56 comes here. Now is it heap tree? Yes. What is output? 23, 54, 89, 66, 56. You observe. See, 23, 54, 89, 66, 56. Okay. Right, this one I'll explain. Is it or? See, it will maintain as a minimum heap tree, complete binary tree, binary tree. Okay, these all properties maintained. You observe first 56. 56 stored here as a root. Next node is left side. That is 23. That is 23. Okay. Next node is 89. Okay. Next node is 66. Next node is 54. First of all, is it complete binary tree or not? Yes, it is complete binary tree. Okay. You observe node numbers 0. This node number 1. This node number 2. This node number 3. This node number 4. Any node is missed? Without missing node number, if the tree is there, that tree without maximum 2 child node, that is complete binary tree. But is it heap tree? Is it heap tree? No. Just you write this one first. It is a complete binary tree. But it is not a heap tree. It is a complete binary tree, but it is not a heap tree. It is a complete binary tree, but it is not a heap tree. Okay. First, what is complete binary tree? It is a binary tree without missing node number. Okay. That is complete binary tree. What is binary tree? In a binary tree, each node maximum 2 child nodes only. Maximum 0 also valid, 1 also valid. Okay. Now, is it heap tree? No, there are 2 types of heap trees, minimum, maximum. It is not minimum heap tree, not a maximum heap tree. If minimum heap tree here, what is the number should be there? 23. If it is maximum heap tree, 89. That is not there, this is not there. But not only this one, every node we have to check. First, here, last element onwards, compare. Now 54, 66, 23. In these 3, which is list? 23. It is okay. It is okay. Now, this one, compared. Now, which is list? That's what it is modified as 23. It is modified as 23. Here, it is modified as 56. Now, is it heap tree? No, because these 3 also again compared. Again, it is compared. 56, 66, 54. Which is list? 54. So this one comes here. It is 54. It is 56. Then what is output comes? 23, 54, 89, 66. Okay. See, 23, 54, 89, 66, 56. Write this output. Now, write again this tree. That tree, leave it. Again, we'll write this one once again. It is a complete binary tree and it is a heap tree also. It is a complete binary tree and it is a heap tree also. It is a complete binary tree and it is a heap tree also. This is the output comes. Suppose here, if we delete one element, if we delete, then output totally changed again. Okay, if we delete element, it is priority queue. What in this queue? This is front side. This is rear side, which is deleted. Insertion at rear end, deletion at front end. What is deleted? 23 deleted. But after deleting, output not the same, the remaining. Again tree changed. Again, actually what will happen? This 56 comes here. The 23 deleted. After that, 56 comes here. Last element comes to top. Last element comes to top. After that, this 23 deleted. Again now compared. This 66, 54. This is the list. Okay. 54, 89, 56. What will happen? 54 comes here. 56 comes here. Then output 54, 56, 89, 66. Output changed again. That type will be there. Okay. See, if you delete pq dot remove system dot out dot println pq. Compilation, execution. See, 54, 56, 89, 69. Now, here previously what is there? See, 23 deleted, 54 okay, but 89 not here. 3 change, you know? This will be happen. Okay. No need to write, leave it. The concept is like this. This is about priority queue. Okay. Next one. Next one. Array deck. Last one, array deck. What is array deck nodal? It is an implementation of double-ended queue. It is an implementation of double-ended queue data structure with array representation. It is an implementation of double-ended queue data structure with array representation. It is an implementation of double-ended queue data structure with array representation. It allows both insertion and deletion at both the ends, front end and rear end. It allows both insertion and deletion at both the ends, front end and rear end, because it implements deck interface. It supports both homogeneous elements and heterogeneous elements. See, this category maximum theory part is there. It supports both homogeneous elements and heterogeneous elements. It allows duplicate elements. It does not allow null values. Your default initial capacity is 10. Your default load factor is 100%. Your default initial capacity is 10. Your default load factor is 100%. Your insertion order is preserved. Your insertion order is preserved. In priority queue, not preserved. Okay. In priority queue, insertion order is not preserved. Duplicate, null value, initial capacity, load factor, insertion order, homogeneous, heterogeneous. These all about array deck. It is array representation, double-ended queue. All concepts over, no? See. Is it over? array deck AD equal to new array deck. AD dot add. Here, add first, add last methods, because both side you can insert. That's what methods are like this. Write the program. It is nothing, very simple. Write the program. Add first, add last, add first, add last. Like that you can add. Both side you can add. Both side you can delete. So this topic is most important for interviews. Remember these points. Most important. You attend any interview, they'll ask questions from collections as well as Stream API. Stream API nothing but not Java streams, collections related. New feature further comes. Is it over? Your output, how it comes, you observe. First 83 added. 83. Add first 80. Before this added. Add last 81. After this one added. Again add first 44. Here added. Add last 91. Here added. This is output. So first what will happen? See 83. 83 added. It add first 80. At the beginning added. At the beginning. So before 83. It add last 81. After last element added 81. Again add first 44. 44 added. Add last 91. 91 added. This is output. Like this output comes. This output. Now, if you want to delete, what we can delete? 44 we can delete, 91 we can delete. Without deleting these two remaining, deleting not possible. Okay. Every data structure, some formula is there. Or that formula it maintains. If it is not maintained, all are arrays only. Then no difference. Then these many classes not required, these many concepts not required. If all are allowed means. Okay. Is it over? This is array deck. Next, write it. The hierarchy of queue and deck implementation classes. The hierarchy of queue and deck implementation classes. The hierarchy of queue and deck implementation classes. Say order, object, abstract collection, abstract queue, array deck, priority queue. Up to here, general purpose implementation classes completed. Is it on? We'll see continuation tomorrow.